Okay, hello. This is AP Statistics. It is April 10th, about noontime. So let's kind of review where we're at. Obviously, we're not at school. And we are looking at hypothesis tests this week with proportions. And we've done a couple of lessons on that, and I want to do it again. I want to talk about just our routine that I'm developing. I hope you're with me here. We've been having a lesson on Monday, Wednesday, and Friday, and problems that go along with it. Hopefully you're keeping up with these. And what I've been doing on Monday mornings, I kind of evaluate whether you did it or not from the week before with a P0, P1, or P2. That's been going along. If you have different people have emailed me saying they've been having some problems at home or so forth, that's fine. Just let me know. Just keep the communication lines open. So keep that in mind. So today we're going to do another hypothesis test. But before we do that, we have a special guest today. We've had Mr. A few times, but today we have a different special guest. This gentleman knows something about AP statistics because he took the class. So without further ado, I present to you my son, Zachary Childs.
Hello, class. AP Statistics 2020, the year of the coronavirus COVID-19. Like Mr. Child said, my name is Zach, and I took this class in the year 2013 and 14. And as far as I know, you probably will have an AP test sometime, to be determined, because we don't really know what the future holds. And my experience in AP statistics, just for a little background, I was a little bit unmotivated that year because I had something that many students call senioritis, as I was a senior in high school, and I kind of lagged along in the class, but I kept up. And by the time the test came around, I kind of pulled things together and I ended up passing the course, which made me very happy in the end.
Not to mention me.
And it made my father happy because it would be pretty embarrassing for the son of the teacher to fail the test. And I think all of you have the potential to pass the exam once it comes around, as long as you stay focused and put in some effort. So I'm going to help my father out today with this lesson.
Oh, isn't that great? I'm so excited. So once again, I'll give him a round of applause for that. I've been wanting to give you, a lot of times there can be negativity and kind of a cynical view on passing a standardized test. Here we go. This guy did it. You can do it. You can do it. So study hard. Remember, you're going to have to study some more than just the little lessons we're doing. But there are plenty of resources online, and you can do it. I know you can. Today, we want to take a look at hypothesis test again and kind of go through the whole deal like we did in the last two classes. And I would like you to look at page 456 again as kind of a guide. And we've been doing the coronavirus for a couple of times. I wanted to try something different today. And I asked Zach, actually, if he had something he could think of. And he came up with this. And it is what? What'd you come up with?
we bounced a few ideas around, and we finally thought of something that is applicable to probably your lives, potentially, we'll see. And just about everyone knows about it. It is social media, and specifically Facebook, FB.
So Zach looked up online, and we found out that approximately 70, whenever this statistic was given, 70% of people are on Facebook. So if you remember from our hypothesis test, this H sub 0 colon means the null hypothesis, which is the established truth. The established truth is, he found it at 70%.
70%, and that is among all individuals. That's among adults, because obviously children under 10 don't have it. It's not among the U.S. This is the U.S. population adults.
Right.
It might be different for high school age. I'm sure it's probably higher, actually, for certain individuals. But for adult age individuals in the U.S., it's 70%.
Okay, so just some of the mechanics of these hypothesis tests. Keep in mind that, first of all, the old HO colon, P means the proportion. Null hypothesis is always equal to. Now we need an alternative, so HA colon P. Now it can be either greater than, less than, or not equal to, which would be on both sides. But what would you think if 70 wasn't right? What would you think, Zach, what the trend might be that it's wrong? Greater than or less than?
What do you mean? What?
If we prove this is not right, do you think the answer probably is greater than 70 or less than 70?
I would think it'd be less than 70.
Less than 70. Maybe, and let me give a scenario that maybe sets this apart. There have been lots of problems with security. People are getting ripped off because they're taking their personal information and selling it. So maybe that is we don't know for sure, but that is a reason why. So our alternative hypothesis is 70%.
Less than 70% of
Yes,
people
less than 70. Thank you.
have a
Where'd
Facebook account.
Where did my eraser go? There it is.
It's the eraser.
Okay, Zach, could you read the assumptions and conditions right here? And let's, well, I'm not going to write them down, but let's kind of talk through. Read me the first one.
So first of all, the independence assumption. There is no reason. Okay, do you want me to give this?
Just the independence assumption.
Independence assumption.
Okay, independent mean there would be no influence from one person to the next. So you're going to have to take it for granted that Zach and I, when we do the sample, that we conducted this independently. And
you want to write these assumptions on the board?
Well, all right. If you push me, I guess I can. Independent. Okay, so it was independently collected. Next one.
Random sampling condition.
Random. The data was collected randomly, and we'll see that in just a second. So I'm going to write A and C, assumptions and conditions up there. Next.
The 10% condition.
10% rule or condition? Is it condition?
It says condition in the book.
All right, we'll give it the 10% condition. Now, we haven't said yet what our sample is going to be. We've kind of jumped around. Let's say today it is 2,000 Americans. So I'll write it over here. N equals 2,000 Americans. And do you think 2,000 is less than 10% of all Americans? 200 and what? 30 or 40 million Americans?
I don't know.
Something like that. So
I-
I think it's well below 10%.
I thought it was more than that, but yeah.
Yeah, well, maybe you're right, but it's way below 10%.
That's below 10% of Mainers. So
N times P, and this is the six. Oh, I should write that down. What it is? Success, failure. I hope you're following along. What was the page again?
we are on page 457. If you're following along,
Success, failure, which is N times P, N times Q greater than 10. 2,000 times 0.70. Give me that. No, actually, let's do the lower one. 2,000 to Q. 2,000 times 0.30 is.
oops, your battery's low. 2,000 times 0.3 equals 600.
So 600 is way greater than 10. So we're all set. Assumptions and conditions have checked out. Now our big formula here is z score equal to p hat, which is the sample,
P hat's the sample. Okay.
minus p null, which is the null hypothesis,
0.7.
divided by standard error, which for us with proportions is square root of PQ over N. Okay?
What is this formula called? What is this equation?
A Z, we are trying to find what is called the P. Remember the P value. Zach already the other day, what did you immediately say when we talked about P value? It kicked right in.
Because of where my mind goes, when the P is low, you got to reject
HO, yes.
HO.
See, he remembered that from 6 years back. See, that locked right in.
Or, because I'm not as, when the P is low, reject
Careful.
HO.
Careful. Okay. Here
We're
we
high
go.
school students.
Figure
All
it
right,
out.
figure it out.
All right. So P. Now we've got to talk about our sample now. We're 12 minutes. So Zach, what we were going to do for the sample, just for the fun of it, to make it kind of random. It's not really realistic, but you know how we love to do random numbers. I do anyway. So
it's fun. Math, statistics is fun.
So we are going to say 0 to random integer, 0 to 1, and 1 at a time. Okay, 0 is going to be a Facebook person, and 1 is going to not be. All right.
Okay.
First person, what?
You press enter.
Yes.
0.
So that's that. All right. We'll say F, NF.
So 0 represents a person who has a Facebook account.
All right. Good. Next.
Okay. It is another 0.
All right.
And we have another 0 for the third entry. Another Facebook user.
Third.
So this is the fourth now.
Yep.
And it is another 0.
Oh, no. Let's not get 10 zeros. This won't be any good. Go ahead.
We got a bunch of Facebookies. We got a 1 here.
Yes, good.
Someone who is not on social media.
All right, next.
0.
Next.
1.
Next.
1.
And next.
0.
Okay, this actually no, that's 9. One more.
Oh. 0.
Yes.
Wow.
No, that stinks.
That's not good.
No, that will stink.
You know what?
No,
Actually, that last
that
one,
was
I
a
made a
1.
mistake. That was actually a 1.
Take his word for it. We're going with a 1, and we're going to say what? Our sample, 6 out of 10. 6 out of 10, which I really like. That's actually going to help us.
I did a good job, right?
So 6. So P hat is equal to 60%. Okay? And we already say N is 2,000. I believe we can do it now. You ready?
P hat 60.
P hat is
0.6.
And what's next, Zach? Minus.
That would be minus 0.70.
And now for the square root. And when you do the PQ over N, make sure it's the null P. So 0.7 times 0.3 divided by 2,000. Could you give me that?
Okay. How do I get out of this mode? Okay,
Right.
I got it.
All right. Square
All
root.
right.
Square root.
So square root. It's been a while.
0.7
Point.
times 0.3 divided by 2,000.
Okay, hold on.
And go out 3 spaces.
Divided and then divided by
2,000.
And it is 0.010.
010. Okay, that's a good one. Okay, so we are figuring that z-score now. So give me 0.60 minus 0.70 divided by 0.01.
So it ends up being -10.
Divided by 0.01.
Divided by 0.01. Negative or 1,000. -1,000.
Whoa.
Did I do this wrong?
All right, hold it. Let me look at that square root of PQ over N. Square root of 0.7 times 0.3 divided by 2,123.
Because we're looking for a z-score.
Yep. You got it right. And now
It should be -0.1 divided by 0.01.
0.6 minus 0.7 divided by 0.01. I get -10. -10.
Yep.
Now, here we go. Let's see what you remember. With z-scores, -10, 10 standard deviations below. What are you thinking for a probability? Really low, I bet. Yep, I hope you are. So that's one of our z-scores. Okay, let's see Zach's memory. What is the other z-score going to be with less than? What did we used to call that? Less than on the normal model. Way down there.
Oh yes. The tails. What? -99.
-99.
I thought it was a word.
Okay. So those are our 2 z-scores right there. So where you're going to look, you're going to look on the distribution normal CDF and put -99 and -10. And it's basically 0. It's so low, so low. I think we're going to have to check this with the calculator and make sure no errors were made. Anyway, the p-value is incredibly low. P is low. So let's check it right now, just so we'll see if we made it a mistake or not. So let's look at stat, over to tests, and we want one proportion z-test. P null is 0.7. The success rate would be 0.6 times 2,000. So it would be 1,200 out of the 2,000. And then we wanted less than. So let's see what we get for a p-value. P-value equals 0. Now, that's kind of that doesn't happen very often. But guess what? If you're all the way down so far that p is equal to 0, would you agree that that's pretty low? Yes. So now we're to our decision, and say how you make your decision again. This is our p-value.
The p-value.
We were hoping it would not be 0, but that's what the calculator says, and that's what we figured out. So what do you do with
when the p-value is low,
you
reject the null hypothesis, the HO.
So we're going to reject. Okay, we're going to reject because if no other guide is given, it is 5%. If it's lower than 5%, you're going to reject. Okay?
Mm-hmm.
And now the final thing I would like to say is the p-value interpretation, which is this. If p null was true, 70%, then the sample, 60%, would occur 0% of the time, which means it would hardly ever occur. So that is, I think that covers totally what we would want to do. Let me just double check one more time. So we on our, with the calculator, if you do it again with me, I'm going to stat over to test, down to 1 proportion z test. The null was 70%. We said, why don't we even do that? 6 out of 10. 6 out of 10. No, n wasn't 10, was it? It was 2,000. So we got to keep with the 1,200 out of 2,000 and less than. Oh, this time it actually gave, look at that. It actually gave me a p-value. But guess what? It is 1.71 e to the negative 22 power. That's a really small number. So it's incredibly small.
So what does that mean in terms of conceptualizing this, thinking about it? Like, if we drew that many people so the 1,200 out of 2,000. So what it would, when you explain this to a person, what does that mean as far as?
It means thank you, by the way. The original thought was 70% of people have Facebook.
That's what the statisticians are telling us.
Right. We're saying, based on our sample, that, hey, with a p that low, it's not 70%. Yeah. It is less than 70%. Yeah. Okay? Now, keep in mind, I really hate, I'm actually going to write it down here because I hate having a p-value of 0 because this is supposed to be a continuous model that never gets to 0. So we're going to go 1.71 e to the negative 22 power. And that's what you call a really low p-value. Where are we at on 23? I don't want to make this too long. So let's do this. Let us do this. Let's say that we're going to do the same problem, but we're going to have you say, because of this coronavirus and everybody wanting to communicate with everyone else, let's say it is 75%. That p is 75%.
So it's increased.
And we want you to, and we're saying maybe it's even more than that. Maybe it's even more than 75%. And we will give you a p hat value. Actually, we'll erase all this. We will give you a p hat value of, let's say 0.748. And a n value of
erase that other n value.
Yeah.
I got you.
An N value of 1,500. Okay? So you go through and do the same thing now. Let's review just so we're not clear. Your problem says people on Facebook, 75%. We're wondering with all this hysteria of coronavirus that people are joining because they want to talk to one another. It's 75%. We took a sample, you took a random sample, and it was 70.748, and that you sampled 1,500 people. Okay. It's time for you to do it now. So send me on an email.
Let's put it right up close to the thing so they
Oh,
can.
thank you. 'Cause there was some confusion with that.
So there we go. Here is the problem that you have to do right here. There's a little glare, but
Okay.
Yep.
Thank you very much, Zach. That was a good idea.
take a screenshot or whatever.
And why don't you wish them adieu here?
Yes. So I hope you all enjoy the learning here. It was a good refresher to me, just for some motivation here to work on statistics. Even though this was all kind of a little blurry for me, I still understood the concepts a little bit, even though it was over 5 years ago that I did this. And it's, as you can see, it's very applicable to our lives today in many different ways. You can share this with your family. You can share these examples with your friends, and you might end up using it in your career someday. So I wish you well, and I might see you again in another
Yeah.
lesson.
I wouldn't be surprised. All right, hold it. Let me see.
So here
Thank you.
is Mr. Childs.
Thank you. So let's just summarize. We have looked again at hypothesis tests. Today dealt with people on Facebook. And so if you could follow that model of 456 to 458 and use the data that we used in there, that would be great. I hope you have a great weekend. And like I said, we'll get back to you on Monday. See you later. Bye. There.
Boom.